In the field of cognitive research, there are many interesting questions still left unanswered. To answer these questions, cognitive researchers are using computers to create experiments. These experiments usually involve integrations between a computer game and measurements taken on a subject as he or she plays the game. We have developed a platform for easily achieving these integrations. Our platform is a communication server that handles all the information flow between the different components of an experiment. Let's say we want to build a research environment to test if and what shapes and colors draw more attention from people. We would want to create a simple game to display shapes of different colors to the subject, while tracking his eye focus on the screen and analyzing his brain activity. We will first need to plan what components to use in the experiment and how they should interact. We will use 4 components in our environment: an eye tracking device that tracks the focus of the subject's eyes on the screen, a display handler to show shapes of different colors to the subject. It needs to get information on what shapes to display and where the subject is looking. An EEG cap analyzes brain signals in response to events in the experiment. It extracts features after the subject looks at a shape. And finally, a controller that decides on what shapes to display given the subject's eye focus and brain activity. We've created a configuration file to represent this scheme using the server's component command, which defines communication paths and their components. We can now load our configuration to the server and run it. The server user interface is a command line-based interface we have developed. As we can see, we need to use the read command to execute commands from a file. We type in the command and enter the path to our configuration file. We can use the built-in autocomplete to specify the path quicker. We can see that the configuration file was executed. When we press Tab to autocomplete, we can get suggestions for possible commands and their expected arguments. We can see a suggestion for the component command we've used earlier. In fact, we can add any command the server can execute to the configuration file. So, we will go ahead and add a command in the configuration file to automatically activate all communication paths. We'll also open a port for remotely controlling the experiment and add some colored comments to be printed as well. We'll now drop the old configuration and reload it to see the results. As you can see, the server has started to accept incoming connections from the different components. Back to our shapes experiment. We've created our scene using Unity. It tracks the focus of the subject's eyes on the screen while displaying shapes of different colors as instructed by the controller. As the experiment takes place, we can control the experiment remotely using our provided remote controller. We will connect to the port we've opened, and now we can start controlling the experiment. We can tap one or several communication paths to control them. We start by tapping the path that tells the EEG what shapes the subject looks at. We can see every shape the subject is looking at as it happens. We move on to tapping the path that Unity is using to know what shapes to display. As before, we can see the description of all shapes displayed to the subject. Now we will enter a message of our own to display 4 crosses with random colors. We can see that Unity displays our shapes to the subject as we send the command. Building an experiment like we've seen is easy using our platform. For the programmers who use our platform, we have defined a simple socket-based API for connecting components to the server. We also provide plug-and-play modules for Python and Unity to handle all communications, letting the programmer focus only on developing the experiment itself. We can use our platform and modules to easily create more complicated experiments like this example. A subject is controlling a vehicle with a mounted machine gun. The machine gun aims at the focus of the subject's eyes on the screen. Features extracted from the EEG cap monitor the amount of surprise of the subject as he looks at objects in the scene. EEG features affect the movement of the vehicle. We hope that our server can be used to create many experiments and games. Thank you for watching.